and welcome back to CHM1032 Lab Online. I'm your host, Dr. Russell Betts, and today we'll be experimenting with energy and matter. In part 1 and 2 of today's experiment, you'll be learning the differences between exothermic and endothermic processes. You'll also learn how to calculate the transfer of heat in calories. It's going to be kind of fun. It's really, really cool. What happens is some experiments get hot, some get cold. Energy's moving. Where's it going? That's the fun part. In an exothermic process, the energy is going out of the reaction and into the surroundings. In today's experiment, the surroundings happen to be an aqueous solution. So the solution the reaction is occurring in is getting hot. Now the reactants are giving off that energy. Okay? The two things are colliding and they make a bond or they do something cool and energy is given off and the surroundings get hot. You can feel it with your hands if the reaction's hot enough. Sometimes it's so hot it'll boil water, believe it or not. And in an endothermic process, things collide, bonds make, bonds break, things happen, and the surroundings get colder. Why is that? Because the chemicals, the surroundings are giving their energy to whatever's reacting or whatever's being dissolved or whatever process is going on. But the surroundings have to give their energy to it to make it go forward. Okay? So exothermic, heat is leaving the chemicals. Endothermic, energy or heat is entering the chemicals. How does that manifest itself? Well, the surroundings cool down in an endothermic process. The surroundings heat up in an exothermic process. Now, this process can be either a chemical reaction or a physical state change. We're going to see both today. And the surroundings of the experiment is an aqueous solution. Okay? Very cool, very cool. It's going to be fun. Now, to do this experiment, you're going to need to know the heat equation. Heat equation. Now, this might not be very clear to you, this funny scripted X. This means to multiply. So it's mass times, there we go. Those little scripted X's there, they look cool, but maybe you don't see them very well on your phone. They're just mass times specific heat times change in temperature. Where Q is the abbreviation for heat. M is the total mass of solution. That's an important concept. C is the heat capacity. We'll talk a little bit more about that in a minute. And delta T is the change in temperature. Because obviously if things are getting hot or cold, we can measure that with a thermometer. Heat capacity. Heat capacity is defined as the energy required to raise the temperature of 1 gram of a substance by 1 degree Celsius. Today's experiment, we're measuring the change in temperature of water. So we need to know the heat capacity of water. And luckily for us, the heat capacity of water is 1 calorie per gram per degree Celsius. That means to heat up 1 gram of water by 1 degree, it takes 1 calorie. Okay? So remember this, maybe write it down. You're going to need it for the calculations in today's experiment. Very simple. Change in temperature, delta T. Delta T is always written this way, the final temperature minus the initial temperature. So before the experiment occurs, you're going to get a temperature. You're going to write it down. It's called the initial temperature. Initial just means before anything starts, here's my temperature. Final temperature. The final temperature is after all the cool stuff has happened, what is my final temperature? Or what is the highest temperature this process got to before maybe it started to cool down? Because remember, after a process is over, the heat will equilibrate back to room temperature. Now here's an example. A solid ionic compound with a mass of 10.525 grams was added to 50.0 grams of water and had an initial temperature of 24.0 degrees Celsius. How many calories were transferred if, after thoroughly mixing the solute, the water temperature increased to 27.9 degrees Celsius? So we have to do two things here. We have to calculate calories from here, and we have to tell the asker if it's endothermic or exothermic. Well, easy. It's getting hotter. It's exothermic. So we can answer that one right away. I can just circle exothermic. It's getting hotter, so it's definitely exothermic. Now, remember, Q equals mass times C times delta T. Well, the C is the heat capacity of water, because this is done in water, right? It doesn't say, but let's assume it's in water. 1.00 calories gram degrees Celsius. So that's C. That's just going to be put in here. C is a constant, by the way. Every substance on this earth has a heat capacity. Water just happens to be 1 degree Celsius, 1 calorie per gram per degree Celsius. The mass of the solution, well, we know we have 50.0 grams of H2O. Oh yeah, we do know it's aqueous, it's in water. Plus 10.525 grams of solute. So we know the mass of the solute and the mass of the water. So we can just do a quick addition here using our handy dandy calculator. So we have 60.5 grams of solution. And that's just going to go here. So we've got 2 of the 3 things we need. Let's do the 4th thing, or the 3rd thing, pardon me. So TI, let's do TI, and then TF. The initial temperature was 24. And the final temperature was, so delta T equals TF minus TI All right, so let me bust out my handy dandy calculator again. So that's going to be 3.9 degrees Celsius. That's my delta T, and that's going to go here. That's the setup. That's how you put it all together. Now, a lot of times students will leave out units when they do this question. Don't do that. Put your units in. Units will tell you sometimes, or most times, when you've done something silly, like divide when you should have multiplied. Cal is an abbreviation for calorie. All right, and start canceling units. Left with only calories. So that tells me that, first of all, I'm doing everything right. Everything's set up correctly. It doesn't tell me if I did these numbers right, though, so make sure you're careful with those. Now, this is just telling me to multiply 60.5 times 1 times 3.9. And the answer is 240 calories. 240 calories. There you go. That's how many calories were transferred from the materials, the chemicals, to the water, or from the ionic compound to the water. All right, class, now with that, I want to wish you all good luck and good chemistry. We'll see you soon.